So we were looking at concepts of basic object-oriented programming in C#. And as we have discussed, there are three concepts, right? Encapsulation, which basically means creating a class, okay? And not only we put the related data and the related functions inside the class, okay? Pretend these are the variables or the data, the boxes are the functions or the methods, right? We also wanted to follow good object-oriented programming principles. In good object-oriented programming, so in good OOP, we keep data hidden. And how do we indicate the data is hidden inside the box? Through what type of keyword? Private keyword, right? So the data is always marked private. So for this to be useful to the programmer, the methods over here are public. So the functions are also called methods, right? Okay, so that's the encapsulation mechanism, meaning take related data, related methods, put them in some kind of a class. We may give it some name, for example, class student as an example, right? Okay, so we created the student class last time. And for example, we put, rather than 2 fields, we put 5 fields over here. And we added, for example, one method called compute break last time, if you remember, right? Okay, so when we are creating a large application, we don't just create one class, we create many classes. Okay, so this is where the inheritance comes into play. So inheritance, basically when many classes are created. Okay, often they have common things in between them. So that's the basic idea in inheritance, okay? Rather than copying and pasting those common things, we take those out and create what is called the base class, right? So for example, let's pretend we are creating a university application. Okay, in a university, let's pretend we will have, let's pretend we have 5,000 undergraduate students. And let's say we have 2,000 graduate students. Okay, and let's pretend we have 100 PhD students. Okay, and let's pretend we have 500 part-time students. So, as we discussed, anytime you have to create an application, the first question that comes to, where a lot of people get stuck is, where do I start? Okay, so the starting point is always to identify the entities that exist in our real life. Okay, so that exist in real life. Okay. For example, in this case, in a university, these are the objects or entities, or however you want to think of it. These are the real things that ultimately we need to store data for, right? So we'll start out by creating a class for an undergraduate student, class for a grad student, class for a PhD student, class for a part-time student. As we are writing the code for these, we'll recognize, hey, we are repeating things, okay? So this is where the inheritance comes into play. We'll take out the common things and move them to a base class. This way, the total amount of code that we have to write will be less, okay? So see, the goal of inheritance is, very simply to write less code, okay? Because they've done studies, if you create a large application, okay, If you have, let's say you wrote 100,000 lines of code in creating an application, right? Somebody creates the same application in 20,000 lines of code, okay? Which one is easier to maintain? Of course, the less lines of code, it's easier to see, easier to change, easier to modify. So that's why whenever we do programming, our goal is to write as less code as possible, right? And that's why, you know, even in the programming languages, okay? Somebody might say, oh, you know, why you have to write it in C#? Why don't you write it in some language, X, for example, right? Okay, sure, anything you can do over here, you can do it in another language, for example, Java, C++, and so on. But ultimately, what if it takes you shorter time over here? What if the total amount of code is less over here? See, that's what will dictate, for example, if one language is better than the other, right? Okay, so even in C#, for example, if you, remember I said when it was introduced in 2000, the version of the language was 1.0, then 2004, 2.0, and so on. 2015, the version of the language, I forgot it's 5.0 or 6.0, one of the two, right? So the same code, if you write it now, you'll be surprised if you wrote it back over here, it's like 10 times shorter, okay? So anyway, we'll come to that part as we go along. But fundamentally speaking, why do we do inheritance? So that we write less code. Okay, so the question is, what is the key idea in inheritance? So last time we did a small example, okay? We created a class called student, for example. Okay, and in this student class, we had 5 fields, if you remember. First name, last name, ID, test 1, and test 2, right? And we also wrote one function over here, compute grade. Okay, and let's pretend this compute grade first computes a weighted average where 40% of the weight is given to test 1, 60% of the weight is given to test 2, let's pretend. And then based on that, if it is greater than 90, the grade will be A, and so on, okay? So we wrote this class, right? So because we are creating a university application, after creating a student class, or let's call it undergraduate student, rather than just a student. Okay, so let me change the name to undergraduate student, right? So now you start to create a grad student, okay? So let's start writing the code for grad student. So as we discussed last time, will a grad student have first name?
Yeah.
Yes.
Last name, ID, test 1, right? So the first 5 fields will be the same. So one option is we just copy it over here, okay? Now in inheritance, the rule is, okay, you inherit everything from the base class or the parent class, okay? Okay, so to clarify this, let's say you created some class called X and you put 3 fields and 2 methods over here, right? Then you created a class called Y. Okay, and in C#, remember we use the colon syntax to indicate we are inheriting from X, okay? So if we just write this and we don't type anything, any code in it, just the begin curly, end curly, okay, as far as class Y is concerned, will it have these 3 fields?
Yeah.
Yes. Will it have these 2 methods? And that's what I meant. You inherit everything. So if you have X number of fields, you will inherit those. You have Y number of methods, you will inherit those, right? So you inherit, in this example, the 3 fields, 2 methods will all be available over here. Okay, now the other rule in inheritance is, okay, you can add more fields or methods, your choice. So as you inherit, so in class Y, you can add more things if you feel like it, okay? So for example, if I put 2 more things over here, 1 more method over here. So how many total fields and methods do I have in class Y as of now? So 5 fields and 3 methods. 2 are being inherited, 1 we added extra. Okay, so that's perfectly okay. Not just C# and Java and C++, all languages that follow the object-oriented programming, these rules are universal. Okay. Now the next rule you need to remember is, again related to inheritance, is okay, so one more rule, okay, you cannot delete an inherited field or method. Okay, so for example, okay, let's say you don't want the top field over here for whatever reason, okay? If you inherit it from here, you will always get this. There's no way you can remove it, okay? So because of these 3 rules of inheritance, you inherit everything, you can add more things, you cannot delete anything that you are inheriting from, okay? When we use inheritance, okay, we try to, okay, so let's say you created some class X, it has a few fields, a few methods, you created a class Y, let's pretend, it has a few fields, few methods, you created a class called Z. Okay, let's pretend it also has few fields and few methods, right? Now let's pretend after you created the 3 classes, so far there's no inheritance between them. Okay, it turns out this is same as this one, also same as this one, okay? And let's pretend this blue method is same as this blue method over here, and also same as this blue method. So 100% same code, same signature, okay? And let's pick one more item. Let's say this field happens to be same as this field, same as this field, okay? So these 3, the 2 fields, if it's the same color, pretend they are the same, and the blue method is the same in all 3 classes, okay? So after writing these 3 things, if we were to now reduce the amount of code, okay, this is what we will do. We'll create a class called, let's call it base, or my base, okay? And in this class called my base, what we will do is, we'll take out all the common things and move it over here. So the red field will be moved over here, the black field will be moved over here, the blue method will be moved over here. Okay, so after moving it to the base class, okay, now as you can see, there's no need to write the code for the field, code for the method over here. If we inherit from here, we will inherit everything, right? So this is what we'll do. We will say class colon my base, or let me call it, for right now to save space, let me give it a name, class B. Okay, so how do we do inheritance in C#? We'll say class X colon B, right? That means we are inheriting from B. Now, according to rule 1, we inherit everything. So do we have to declare these 2 red and black and the blue things over here? No. So we can remove that code. We can remove that code. We can remove the code for the blue part, okay? So as you can see, we are left with very tiny code over here. and that's the goal of inheritance, right? Now let's go to class Y. As we discussed, these, if we inherit from here, we'll automatically get the two red and black fields and the blue method from class B. So let's do the same thing. Let's inherit from class B. Then do we have to write these two fields here?
No.
No. Do we have to write the blue method?
No.
No. So you can see our code is extremely tiny. No fields, just two extra methods that we wanted to write in class Y. Now let's go to class Z. Same thing. If we inherit from our base class called B, then we don't need to write this field, we don't need to write this field, we don't need to write the blue method. So just one extra field, two extra method, and our total amount of code, if you count the total number of lines, including the B, including these three classes, you'll see it will be far less as compared to copying and pasting all the fields in each and every class, okay? So that's the idea behind inheritance. Once again, the goal is to try to write as less code as possible. So now let's come to the university class, okay? Suppose you were creating this application. You created one class for the undergrad students with the 5 fields, and you wrote some method, okay? So let me point out one more thing, okay? If you are given the task to create a new application, okay? What classes will you be creating? As I mentioned, you start out by first identifying what are the real things that exist, okay? PhD students, undergrad students, grad students, part-time students. For example, they exist, right? So you'll create one class for each category, okay? So you start writing the code for the class, okay? Next question. We know that it's a large application, so we will like to write less code, so that means we will like to use inheritance. So how do we know what base class to create, okay? And the answer is nobody knows in the beginning, okay? Of course, you get a little better at it with experience, but even the experienced developers, if they go to a new application, they may not have a clue what base class do I create, okay? So that's fine, don't worry about it. As you will see, creating base classes is like a discovery process. Gradually, you will discover yourself, and you will keep refactoring, meaning keep changing the code in each one of the classes, keep discovering that there's a need for a base class, and you yourself will come up with a very nice hierarchy where we have base classes, derived classes, and so on. Okay, so to show you that, let's go to the university example. So once again, suppose you wrote 5 fields, one method over here. Now you go to the grad student, and without worrying about inheritance, you start writing. You say, oh yeah, we do need first name, we do need last name, we do need ID for a grad student, we do need test 1, we do need test 2. And let's pretend every student will do a thesis, so we need some kind of a thesis to for each graduate student, okay? Now, every student, grad student, let's pretend will also take 2 tests. So we also need a compute grade method. And let's pretend we did not want 40% of the weight to be given to the test 1. We wanted equal weight for the grad student's grading, okay? So we will start writing the code with 0.5 times test 1 plus 0.5 times test 2. And this will be our weighted average, and then if ABG is greater than 90, we'll assign the grade A and so on, right? So as soon as you are done typing this code, you will recognize, hey, we are repeating things, okay? So for example, what things you see being repeated over here? The 5 fields are being repeated, okay? So you yourself will say, oh, you know what? If we created a base class over here and declared the common things over there, then we can remove those over here, okay? So at that point in time, you will go and create a class called, let's just call it student. Okay, not an undergraduate student, not a grad student, but just a generic student, which could be any one of these students. Okay, and now here you will put those 5 fields over here. What 5 fields? The first name, last name, ID, and test 2. Okay, but not the thesis. Why not? Why won't we put the thesis over here? Because it's not common. Thesis is only here. It's not in this student class, right? Okay, so now we will go over here and we'll say inherit from where? Student. Student. Okay, inherit from student, right? Okay. So since we inherit everything, right? Do we have to declare these 5 fields over here? So these go away. Okay. Do we have to put those 5 fields over here if we inherit from student? No. The first 5 fields go over here. The thesis can be added. Remember the rule in inheritance? We can add more fields or methods if we feel like it. Okay. So far so good. So obviously this will reduce the code over here, reduce the code over here. Now there's a small complication, okay? And the complication is we have a compute grade method over here. We have a compute grade method over here. Okay. Both of them return a string, meaning A minus, B plus, whatever, right? Both of them do not take any parameter because they operate on the data inside the class, correct? Okay, so the complication is that if it is a lowercase test2, lowercase test1, right? How is it, if we write it in C#, what's the default visibility of it? Private, right? So that means outside of this class, we cannot see it over here. So if we try to write this code test1 or over here test1 with a lowercase t, compiler will say, I don't know what lowercase test1 with lowercase t is because it cannot be accessed in this box. It's hidden inside this box. Okay, but remember we always expose every field by a public property, which starts with the uppercase letter, right? So, okay, so one option is over here when we are writing the code over here is to, instead of the lowercase t, what should we do? Uppercase t. But anytime we use the uppercase t, what does that mean? It will go through a get function to read the data. Okay? And calling a function is a little bit slower as compared to directly accessing the data, right? So the other option is, instead of using capital T over here, let's go over here. There's another keyword that most of you already know, which means a derived class can see it, but no other class can see it. Protected. So just like C, Java, C++, Java, there's a protected keyword over here. So protected is like private, meaning if there was some class, let's say employee, which has no relationship with the student class, and we wrote a method over here, and if we try to access the test1 over here by creating a student object, let's say student s1, and we try to do s1.test1, okay, so this will be denied access. Why? Because it's protected. Protected only allows access to a derived class, no other class, okay? So over here, now if we use lowercase t, it's perfectly okay because t is protected over here, and this class is inheriting from the student. So protected, once again, is like private, but allows access to a derived class. Okay, now in the object-oriented terminology, When we take out the common things and put them over here, this is called the base class, okay? When we go and inherit from here, then this is called the undergraduate student or the grad student. That's called the derived class or the child class, okay? So base class, derived class, base class, derived class, okay? Anyway, so protected for all practical purposes is private, but it will allow access to the derived class so that it can still use the lowercase t, okay? Okay, so now there's another small complication, and the complication is, remember in good object-oriented programming, as we create classes, we take out the common things and move them to the base class, okay? So what should we do to this compute grade method? At least the signature, as you can see, is identical over here, right? Even though the code is different, okay? So in good object-oriented programming, what we'll do is, as we create this base class called student, for example, we will move this over here, okay? So we will say public, sorry, let me write it a little clearly, public string compute grade. Okay, so now here's the problem. What code do we write over here? So what code should we write in this compute grade method in the student class? Because over here, we do not know whether it will be an undergraduate student, whether it will be a graduate student. Because if it's an undergraduate student, we want to multiply 0.4 with test 1. If it's a graduate student, we want to multiply 0.5 with test 1, okay? So question is, since we have no clue at this point in time, what type of student is it, okay? So does it make any sense to put any code over here? No, so we cannot put any code over here. Okay, so no code. Okay, whenever a method has no code in it, the rule is we will mark it as abstract. So abstract, if you write before a method, it basically means no code in the method. Okay, so if we leave it like this, okay, then the problem is somebody may try to create one object of the student class. So somebody may try to do something like this. Student S1 equal to new student. And then what will happen if they try to call compute grade? Would it make any sense? No, because there's no code over here. So calling this does not make any sense. So to prevent that nobody can even call it like this, okay, another rule in object-oriented programming is that if you have a class with a single method which is declared abstract, the whole class has to be declared abstract, okay? So let me give you the next rule. So rule number 4, okay, if a class has one or more methods declared abstract, okay, the entire class has to be declared abstract. Okay, so how do we declare the whole class abstract? You go just before you declare the class, you put a keyword called abstract. So take a look over here. So the method will have an abstract keyword before, the class will have an abstract keyword before. Okay? So now, the minute a class is marked abstract, that means also you cannot create an object of an abstract class. So a related rule is, number 5, you cannot create an object of an abstract class. Okay, so coming over here, if somebody tried to do something like this, student S1 equal to new student, this code will not even compile. So this will produce a compiler error. Okay, why? Because the compiler will go and check how was the student declared. It's declared abstract, so we'll say you cannot create an object of it. If you cannot create an object of it, obviously you cannot make the call. So it gives us a little more reliability. Okay, so anyway, to summarize, as we are creating classes, okay, we'll take out the common things, move them to a base class. Okay, if there's a method which exists in both classes, okay, if the code in the method is 100% the same, okay, then you will move it to the base class and you'll put the code also in the base class for that method, okay? But if the code is different, but the signature of the method is the same, okay, then you'll move it to the base class and mark it as abstract. As soon as you mark the method abstract, the whole class has to be marked abstract. Okay. Now, C#, very similar to Java, is what we call strongly typed language. Okay. And the idea is also C# emphasizes no ambiguity. So as you're writing the code, if there's any confusion that possibly may occur, the goal of C#, even more than Java, is to eliminate any ambiguity. Okay? So that's why if we mark it as one method as an abstract, the code will not compile if you forgot to mark the class abstract. Okay, so the class has to be marked abstract, right? Okay, the other thing is, so now let's go to over here, to the class undergraduate student, which we are inheriting from student. Let's pretend it's marked abstract. Okay, now as you're writing the code over here, what will happen if you forgot an E over here? Okay, what will the compiler think? The compiler will think you're adding a new method, right? Remember, can we add something new?
Yes.
We can add more fields, right? So to prevent that, any mistyping you may possibly have, and again, coming back to eliminating any ambiguity, okay? C# requires that if the goal was that this method, as you're writing the code, is actually the method that you are inheriting, and now you are providing the real code for it. So in C# you will use the keyword override. So you will write it as public override string compute grade, and then whatever 0.4 times and whatever that code is. So you have to put this keyword called override. Okay, now take a look. Suppose in your mind you were overriding it, okay, and you forgot an E over here. What will happen? Because you said override, the compiler will give you an error saying I did not find anything over here called compute grade without an E, okay? So again, the whole idea about over here is to make sure we have as less ambiguity as possible, okay? So obviously you'll go back and check and say, oh, I forgot the E, and you'll put the E, okay? Okay, so now coming back to inheritance, the next rule, okay, which is I think the last rule in inheritance you need to remember is a base class reference can point to a derived class object. Okay. A base class reference can point to a derived class object. Okay. And again, this is not a C# rule. This rule is for all object-oriented programming language. So regardless C, C++, I mean C#, Java, all have the same rule. Okay. So let me further clarify this part. Okay, so let's go to our example of student and undergraduate student and grad student, right? So if I draw the picture, so far we have a student. We are inheriting from it, creating an undergraduate student class. We are also inheriting from it and creating a graduate student class, right? Okay, so the last rule says if we create a reference, meaning like a pointer. So remember we discussed if we say student S1, does this create the memory to store the data for the 5 fields of a student? No, this is simply like a pointer. Okay. Then if we say further new student or new something, so first of all, if I wrote this code, will this work?
No.
Why not?
Because it's declared abstract.
Because we declared it abstract, so we cannot create a student. But can we create an object of an undergrad student or grad student?
Yeah.
Yes, right? So as you can see, if we did it like this, equal to new, let's say undergrad student. Sorry, I forgot the new. Okay, so then it's perfectly okay. So now if you examine this statement, what do you see over here? What type of reference it is? Student is the base class, right? This is the derived. So as you can see, base class can point to an object of the derived class, which is the undergrad student. So without this rule, we'll be in trouble. Okay, the whole concept of inheritance will not make sense. Okay, so to support the inheritance, we have this rule number 6. Okay, now some of you may argue, well, can't we do something like this? Undergrad student U1 equal to new undergrad student. Will this be legal?
Yeah.
Yeah, this is perfect. So some of you may argue, well, why do we do this if this makes easier sense and it's easier to see what we are doing? And the answer to that is, in a simple application, you can get by with this, but as we create more advanced applications, where we are going to the database and we are bringing students, some of these may be undergrad students, some of these may be grad students, and we wanted to process all of them, for example, in a loop, okay? Then we need some kind of a reference that can point to an undergrad student as well as a grad student as well as a PhD student. So if we have this capability that base class can point to any object, it will make our creating of such a capability or such an application a lot easier as we go along. So in short, we do need this capability as we go along, even though the second one is perfectly okay. Okay, so so once we do that, right? Now let's go over here. If there was something marked abstract over here, so if there was an abstract okay, let's say compute grade public abstract string compute grade. Okay, and remember there will not be any code because here we don't know what that is, right? So here's a declaration in the student class. Okay, now here, as we already discussed, we do need to provide the real code for it, right? So as we are providing the real code for it, so as we are writing the real code for it, how will we say over here, public? Override. So this abstract will become now override string compute grade, and whatever the real code is over here, right? So 0.4 times and so on. Same thing over here, you will do public override and 0.5 times, right? Okay, so a related, I mean it's not a separate rule, but, and this is, you know, special to C#. So in C#, a base class has to give permission to a derived class for it to override a method in base class. Okay, so now let's take the example. Okay, so the abstract and override makes sense, right? Okay, let's go back and now change the situation. The situation now changes like this. Okay, suppose we decide to do this. First we thought both of them will have 0.4 and 0.6. So the code is identical in the compute grade, both for an undergraduate student and a grad student. If the code is identical, then as we move it over here, will we still mark it abstract?
No.
No. Okay, so in that case, this will no longer be abstract. This no longer will be over here. So instead, we have whatever 0.4 times test 1 and so on. So we'll have a real code over here, right? Now if we come to the undergrad student, is there a need to override it now?
No.
No. So if I don't write even the method, so if I take this out completely, will that method be still available over here? Yes. Okay. Now let's pretend it's fine over here, both the undergrad student, grad student, there's basically no compute grade method over here. Because we are inheriting from the student, there's no compute grade method over here. I mean, that we are writing, but we are receiving it from the base class, right? Now we keep creating our applications, and so far we were happy, okay? So the code for the compute grade, real code exists over here, okay? Now we try to create the next class. So suppose now we wanted the PhD student, okay? As we go to the PhD student, and suppose now we realize, oh, PhD student has to have a formula where 0.5 times test 1 plus 0.5 times test 2. It has to have this formula. Okay. So if we inherit, but let's pretend rest of the fields are the same. So inheritance does make sense. So if we inherit it from student, my question is, if we don't write the method for compute grade, we'll get the 0.4 formula, but we don't want the 0.4. We want the 0.5 formula, okay? So what should we do? Okay, see, if you simply, in the class called PhD student, if you simply wrote the method public string compute grade, and you try to do 0.5 times point whatever, right? Okay, you can see there's a confusion. The confusion is there is a compute grade in the base class, there's a compute grade over here, okay? So which one are we talking about? Is we just talking about the 0.4 formula or the 0.5 formula? Okay, and as I mentioned, the goal of C# is to eliminate confusion, okay? So to make it very clear that this is an override, that only for the PhD student we need this, we'll put the keyword over here called override, okay? But then there's a small problem over here. If we are saying override over here, remember as I mentioned, the base class has to give permission to allow somebody to override, right? And the base class gives permission through a couple of keywords. The first keyword is base class can say the method is abstract. So if it was declared abstract, we did an override perfectly fine, okay? Now we need the second capability in the base class to give permission to this one, okay? So there's another keyword called virtual, okay? And I'll explain the meaning of it a little bit more. But if we put a virtual over here, okay, with, so virtual basically means a derived class is allowed to override. Technically, it has a few more meanings, which I gradually will clarify to you. So coming back to our example, we created the student class, we wrote the real code over here, okay? But so that later on somebody can override it and change this code, for example, in PhD student, if we want 0.5 times test 1, then how do we allow that somebody can inherit and override it? By putting the keyword virtual. So in the base class, you have either abstract or virtual is how you can give permission to any of these classes to override, okay? Now let's pretend as we keep creating our application, okay? We wrote this, okay? Let's pretend somebody comes to you and say, oh, UB is starting another program. Okay, if you work in industry, for example, you are a professional developer, you can come and take a course at the university. So let's call it a special student. So special student, let's pretend it's somebody who already graduated, is just taking a course to increase their knowledge, but they do not want a degree, okay? So, and let's pretend the special student also will have, for whatever reason, let's pretend it will have the same fields, or let me make an exception. The special student, let's pretend, already has a PhD, but wants to take a course to increase their knowledge, right? So whatever fields we have in this PhD student, the special student also needs those fields, okay? So we decided to inherit from the PhD student. So class special student. Inherits from PhD student. Okay, for whatever reason, let's pretend we wanted to reuse the code over here, so we inherit from here. Okay, since we are inheriting from the PhD student, and let's also pretend the special student needs a different formula for the compute grade. Okay, needs a formula, let's say 0.45 times test 1 plus 0.55 times test 2. So this is the requirement for the special student for the compute grade method. Okay, so the question is, as we declare the compute grade method over here, what keyword will we use over here?
Override.
Still override, so we will still use override over here. Okay, but we are inheriting from the PhD student, and how is it already marked? Over. So from an override, you can override as many times as you feel like it. So the third way that a class will give permission to another class will be